Hi everyone, so let's have a look at Unit 1.1, which is the particulate nature of matter and chemical change. We'll start with the nature of science. So long ago, scientists thought that matter is made up of something called phlogiston, and when these things would be burnt, phlogiston will be liberated. So meaning that when things burn, they lose phlogiston. This was called the phlogiston theory. However, as they were doing experiments, they found that when you burn magnesium, you actually have an increase in mass. So actually magnesium is gaining something rather than losing what they were calling phlogiston. So this contradicted the phlogiston theory. So as we have more advanced computing methods, instruments and methods, we are able to test our theories to be able to find if they hold true or not. So the atomic theory, which is today accepted, states that all matter is composed of atoms and that these cannot be created nor destroyed, and they are rearranged during chemical reactions. And physical and chemical properties of matter depend on bonding and arrangement of these atoms. This is the atomic theory. Now, you'll come across two terms. You'll come across the term law and the term theory. So a law is actually telling you what's happening, while a theory is attempting to explain what is happening. So that's the main difference between a law and theory. And both of them are developed from experiments, both of them have exceptions, and both of them can be modified or rejected. Now, let's see the law of defined proportions by Berzelius and Proust. So these two scientists came up with observations. So Proust said that a compound always contains same proportion of elements by mass, while Berzelius says that compound does not always have the same proportion of elements, especially in inorganic compounds. So what Berzelius is actually saying is that when we're looking at, let's say, a compound iron 2 oxide, so FeO, Berzelius says that it's not always going to be FeO. So you can have odd proportions, right? And Proust, on the other hand, said that you're going to have the same proportion, so FeO all the time. Now, according to the Occam-Razor principle, a theory should be as simple as possible while maximizing explanatory power. So you'll find that in chemistry, we have lots of exceptions, and this is because of the Occam-Razor principle. We'll try to make things as simple as possible so that we can understand it better. And of course, this leaves rooms for exceptions. So in this case, Berzelius is right, yes, but we are going to use Proust version for the law of defined proportions because this is going to help us understand things in a simpler way. But of course, when we find that certain compounds may not exist in fixed proportions, right? So such compounds can exist. Now, get your terminologies right in case you're still unsure about that. Element consists of only one type of atom. An atom, as you know, is the smallest part of an element. Compound, you can have two or more elements chemically bonded together. A mixture, you can have more than one element, or you can have more than one compound, or you can have, in general, we can say we have more than one substance, but they have to be physically bonded. So this is a mistake. Physically bonded together, and so they retain their individual properties. We have two types of mixtures. Homogeneous mixtures, for example, you have a mixture of salt and water. This is homogeneous. Once they are mixed together, you cannot identify the individual components. Or you can have heterogeneous mixtures. These are non-uniform mixtures. For example, bubble tea is a heterogeneous mixture, so you can identify the individual components. In that you have the pearls and then the tea. So this is an overview of the different types of particles that make up matter. So you can have pure substances or mixtures. So mixtures, homogeneous and heterogeneous mixtures. So homogeneous mixtures, for example, salt, water, alloy. So you cannot distinguish the individual components, but heterogeneous, for example, soil. So you'll have the rocks, you'll have the pebbles, you'll have the soil itself. Salad dressing, you will be able to identify the individual components of that. So these are mixtures. And then pure substances, you have elements and compounds. Elements, you have atoms and molecules. And normally in atoms, you're going to have van der Waals forces in between the atoms. Molecules, these are formed by covalent bonding. You can have covalent bonding between the same atoms. So these will be elements in the form of molecules. And you can also have covalent bonding between two or more different elements. So these will be molecule in the form of compounds, for example, H2O. And you also have compounds that consist of ions. So this is the case for ionic bonding, compounds with ionic bonding. Ionic compounds which consist of formula units.